This lesson is focusing on geometric series. If a sequence is geometric, there are ways to find the sum of the first n terms, which is denoted by s subscript n, without actually adding all the terms. So a geometric series is the sum of the geometric sequence. So let's recall, a geometric sequence is shown by A, AR, AR squared, AR cubed, and so on. So a geometric sequence is the sum of the geometric sequence. So we can write this as A plus AR plus AR squared, and so on, until we get to AR to the n minus 1. So each term is AR to the power of k, where k starts at 0 and goes up to n minus 1. I will show you how to get the formula in another video, but for now, to find the sum of the first terms, or the first n terms of a geometric sequence, you can use the following formula. So we have Sn is equal to the sum of, so remember this means the sum of, from k equals 0 to n minus 1 of ARK to the power of k is equal to A outside of 1 minus r to the n over 1 minus r. So let's use this formula for a question and understand how we use it. So example 1, we have find the sum of the first 8 terms of the geometric series if A is equal to 1 and R is equal to 2. So remember, A is our first term and R is our common ratio. So let's first write down our formula. So we have Sn is equal to, so we have Sn equals to A 1 minus r to the power of n over 1 minus r. So let's state, let n equal 8 from our question, A is equal to 1, and R is equal to 2. So normally you would work down your page, but I haven't given myself enough room, so I'm just going to write it up here. So let's sub in our values. So we have S8 is equal to 1 multiplied by 1 minus 2 to the power of 8 divided by 1 minus 2. When you put this into your calculator, you'll get 255. So the sum of the first 8 terms in the geometric series, where our starting term is 1 and our common ratio is 2, is going to be 255. So let's do another example where the question just looks a little bit different. So it says find S10 of the geometric sequence 24, 12, 6, and so on. So we know that we are going to be finding the sum of the first 10 terms. So n is going to equal to 10. We also know that our first term is going to be 24. So A is going to be equal to 24. And now we need to find our common ratio. So remember, our ratio is equal to the second term divided by the first term. So in this case, it's going to be 12 divided by 24, which is equal to a half. So our common ratio in this question is going to be a half. So now let's find the sum of the first 10 terms. So writing down our formula, we have Sn is equal to A outside of 1 minus r to the power of n, all divided by 1 minus r. So now let's sub in our values. S10 Okay, so we've subbed in all our values, and now when we put this into our calculator, we would get 3,069 over 64. Okay, so our last example that we're going to look at is very similar, but again, it's just displayed a little bit differently. So evaluate the sum of 3 times negative 2 to the power of n minus 1, where n starts at 1 through till 10. Okay, so we are finding the sum of the first 10 terms. So let's go ahead and put this into our, state our terms. So we know that n is equal to 10. We know that a is equal to 3. We know that our common ratio is negative 2. So let's write out our rule. And now let's go ahead and sub in our values. So a is 3, 1 minus negative 2 to the power of 10, all over 1 minus negative 2. So when you put this into your calculator, you'll get negative 1,023. So as you can see in the 3 examples, they've all asked you to do the same thing, to find the sum of a geometric sequence, but they've just been asking you slightly differently, displaying it a little bit differently. Thank you for watching.